Hey y'all, in this video I am going over our review that is going over our concepts from mocks 7 and 8. And in this video, I'm just going over the first set. So I'm going over numbers 1 through 14 in this video. So here, this is just the first few questions were the review on our exponent rules. So here, keeping in mind, right, if I want to know what's the value of y, notice how we have division, but we also have a couple of rules here as well. Like I need to rewrite what's in my numerator. So like in my numerator, I have x to the ninth, right? X to the ninth, but it's inside the fifth radical. So this is x to the ninth, but then over 5. So then here now notice you have a power to a power, which means you need to multiply. So here that's 3 times 4 fifths, which is now 12 fifths. Now that we've got everything rewritten and we're dividing, what did we always do with the exponents here when dividing? Top to bottom, subtract the exponent. So you have 9 fifths minus 12 fifths, which is what gives you negative 3 fifths. So in number 2, this is again the rewriting like in the numerator and then simplifying. So here in the numerator, we've got y to the 12th, but notice how it's inside of that fourth radical. The index is 4, so y to the 12th, but over 4. So then here in the denominator, well, this is y to the 10th. But then remember, right, that's not just y to the 10th. What is the index here for our square root? 2. So this is 10, but over 2. Now notice we can simplify, right? Both of these exponents. So now I've got 12 divided by 4, which is 3, and 10 divided by 2, which is 5. Then same thing again. Notice how here, right? Bases are the same. So top to bottom when dividing, subtract the exponents. This is 3 minus 5, which is negative 2. So I've got y to the negative 2. But notice we can't leave our base with a negative exponent. So that's when we would reciprocate. And we've got 1 over y to the second power. And then same thing here. Again, you're dividing, so we need to subtract the exponents, but the bases have to be the same. So here, s technically, right, has that understood exponent of 1, and we're going to subtract that 1 minus 9 thirds. And so here, the exponent for s now is going to be negative 2. So then same thing with our base of t. We're going to take that 2 and minus negative 3 fourths. So here now you end up with t to the 11 fourths. Now notice we can't leave our answer here as is, right? Because of the negative exponent. So that's why we're going to leave t. So this is t to the 11 fourths, but over s squared. So now moving into our equations and solving our radical equations and cubed root here. So keep in mind, we can't do anything right now because both of the radical, the cubed roots, are on the same side. So we need to add the cubed root here of 3x minus 16 to both sides of the equation. And so now here canceling out, right, because we added it, we now have the cubed root of 12 minus 4x is equal to the cubed root of 3x minus 16. So just moving that over. Because now we can cube both sides of the equation and notice how here by what we do to one side, we do to the other, cancels out both cubed roots. So really you just end up with solving 12 minus 4x, which is equal to 3x minus 16. So in the end, we're setting what's inside equal to each other. Now we're just solving a multi-step. I'm going to add 4x here to both sides of my equation. Now I've got 12 is equal to 7x minus 16. So now notice we're just solving a two-step. We're solving for x here. Add 16 now to both sides. You've got 28 is equal to 7x, and you get x is equal to 4. 7 times 4 is 28. Or, of course, just go ahead and divide by 7, and you get x is equal to 4. So now in number 5, again here, the radical is by itself. So I'm going to go ahead and square both sides of my equation because that's the inverse of our radical here, our square root. So now here, notice you do on this right side have to do box method. So I'll just do that over here real quick. So you've got 2x plus 1 times 2x plus 1. So again, keep in mind, right, you're doing box method or FOIL, whichever you prefer. And so here in the end, you should get 4x squared plus 4x plus 1, which is equal to, right, radical canceled out, so x squared minus 7x minus 5. Now notice we're solving a quadratic, but quadratics have to equal 0. So I'm not going to subtract 4x squared because then I would get a negative 3. So I'm going to subtract x squared from both sides, which means I'm going to get this side to equal 0. So that means now I need to also add 7x to both sides, as well as add 5 to both sides. So again, opposite, get everything to cancel out to equal 0. So the quadratic now we end up solving, or by factoring, is 3x squared plus 11x plus 6. So now we can go through and solve. Now, notice here we've got a is greater than 1. We have a GCF. No, I cannot divide every term by 3 or a common factor. So this is again now when we have to do bottoms up. So this is x squared plus 11x, but now plus 18. 3 times 6, 18. Now we can factor. So what numbers multiply to get 18 but add to get 11? 9 and 2. Now, does that mean that x is equal to negative 9 and negative 2? No, because then remember with bottoms up, right? That a value, whatever we multiply by, we now need to divide by. So we're going to divide now both sides by 3. So here I've got x plus 3 is equal to 3x plus 2, right? Bottom up, which is equal to 0. That means that x is equal to negative 3 and shortcut, right? Just take the fraction here, negative 2/3. Or you could set 3x plus 2 equal to 0 and solve for x and you get the same value, negative 2/3. So is this our answer? Well, no, right? Because now that we have solved by factoring, now we need to check for extraneous and plug back in. Because remember, our radical, we're going to focus only on positive, so we end up with a negative here, then they're not equal to each other. So here we are going to use that 2x plus 1 and substitute to c. So here I've got 2 times, here, so I've got 2 times negative 3 plus 1. Well, that's going to give you negative 5. So negative 3 is extraneous. So now we're going to substitute negative 2/3. So 2 times negative 2/3 plus 1. So now you end up with negative 1/3. Well, still negative. So if both are extraneous, then that means what do we end up with? No solution. Now, how can we check our work that this is a no solution? Well, we can graph this in Desmos. So again, remember when graphing in Desmos, you're going to graph the original equation, right? Not what we used for solving and squaring both sides. We need to graph the left side here and graph the right side here. So when you graph this in Desmos, again, right? Remember, you have the left side, you have the right side. So now notice here in zooming out, do they cross each other? Move the window, right? Move it all around. All right, nothing here. Nope. But I could zoom in a little bit to see here. Do they cross? They do not. So notice how they are not crossing each other. So this is a no solution. And so now in number 6, I'm going to go ahead and erase this here from the previous problem. Notice in number 6, the problem has already been solved. But we're looking to see if there's an error made, and if not, to explain. So here, this equation was solved. So I know here that I need to square both sides first, which is shown. So now they cancel out, and I've got 4x minus 19 is equal to, now this is box method. I've got x minus 6 times x minus 6, which here, x squared and negative 6x positive 36. So here I've got x squared minus 12x plus 36. So does that match? Yes. So far, so good. Then we're solving a quadratic, and quadratics have to equal 0. So I'm going to go ahead to get this to equal 0. I'm going to subtract 4x from both sides and add 19 to both sides to get this to equal 0. So subtracting 4x and adding 19, I've got x squared minus 16x plus 55, which matches again. So now I'm going to go ahead and start factoring. What two numbers multiply to get 55 and add to get negative 16? Well, 11 and 5. But because of the negative 16, I need negative 11 and negative 5 to add to get me negative 16, which again matches. That means here that x is equal to 5 and 11, which matches. But now I'm noticing something, and you should have as well. Are we done? Does this mean that no error was made? No, because this person, Adam here, forgot to do what actual last final step? Check for extraneous. So now we need to check for extraneous to see if we have any extraneous solutions. So that means now, again, we need to plug back into the original x minus 6. So if I've got x minus 6, remember, right? This cannot equal a negative because our radical here, we're going to focus on positive for checking for extraneous. So x is 5. 5 minus 6 is negative 1. So notice 5 is extraneous. Now let's check 11. 11 minus 6 is positive 5. So 11 is technically the only solution because 5 was extraneous. So that was the error here that was made. So now in number 7. Here again, we're just solving for our radical. But now notice this radical is not by itself. We're adding 21 outside of it. So here I need to subtract 21 now from both sides. Now I've got here the square root of 5 minus 4x is equal to, notice that's just 0. So really it's just equal to x. Now I'm going to go through and start solving by squaring both sides. Radical cancels out, and I've got 5 minus 4x is now equal to x squared, because that's just x times to the second power. So here in the end, we're still ending up solving a quadratic which has to equal 0. So leave the x squared, right? We're going to add 4x to both sides and subtract 5 now from both sides. Now I've got 0 is equal to x squared plus 4x minus 5 now. Now we can go ahead and start factoring. And what numbers multiply to get negative 5 but add to get positive 4? Well, I know I need to multiply by a negative and a positive. So this in this case needs to be positive 5 and negative 1. And of course, always check, right? Make sure that they add to get you 4. 5 minus 1 is positive 4, which means that x is equal to negative 5 and 1. Now, we need to check now for extraneous, but in this case, you are not going to plug into the original because the radical was not by itself. So when you're checking for extraneous, you're going to plug into when the radical was by itself. So in this case, it's just x. So can x be, or can our radical be equal to just negative 5? No. So negative 5 is extraneous. Can our equation x just be 1? Yes. So only 1 is the solution. Now, how can you check your work? Same thing again, graph this in Desmos. Because what we're saying is that these two graphs, when you graph them, would only cross one time and x is equal to 5. Now in number 8, which equation has no solution? So now notice we could go through and solve each of these equations until we get to an equation that gives us no solution, where you get nothing but extraneous. But that could be very time consuming, right? So if you want to be strategic and think about what is the best resource or what tools do I have access to, to solve this problem, besides going through and solving each one of them to see what gives me no solution, what can you do? Use Desmos. Because then what would happen if there's no solution? The graphs don't cross each other. So again, make sure to graph the left side, then graph the right side. So let's check A. Well, here is A already graphed. So again, right, I just went ahead and did these, but notice the left side, the right side. So are these two? Nope, because they're crossing here at x is equal to 1. So A has one solution. So now let's go to B. So I'm going to go ahead, cancel these out, and let's go to B. Again, left side, right side. I'm going to move my window out just to double check, and I'm noticing that these two graphs will not cross each other. They are not intersecting. So that's why the answer here is B. Now, just to double check, I still went ahead and even graphed C. So like here, I'm going to graph C. And notice, again, make sure you zoom out, right? If you're like fully zoomed in, and let's say here, you're just seeing this. Make sure to move so now you can see that they do have a solution here at x is equal to this negative decimal here. So here, that's why the answer was B. They are not intersecting each other. And so now here in numbers 9 through 11, we're still going through our equations, but with our application. So here we're given the relation between D, so diameter in inches, and weight in tons for a rope. How much weight can be lifted with a rope with a diameter of 1.65? So if the diameter is 1.65 inches, then this is my value for D. So notice here, that means if D is equal to, then I need to set my equation equal to 1.65 because D, the diameter is 1.65 inches. Now that is equal to, here we go. So I've got the square root of 15 times. Do we know what W is? No, because it's asking how much weight. So that is what we are solving for, divided by 3.14. So now notice we're just back to solving a radical equation. So what do I need to do first? Well, if it's being divided by 3.14, multiply both sides by 3.14. And so now here you get 5.181, which is equal to the square root of 15W. Now, can we divide by 15? No, because everything's inside of the radical. So now we've got to get rid of our radical. And how do we do that? Square both sides. Inverse. So here you get approximately 26.84, which is approximately equal to that 15W. Now we can go ahead and divide both sides by 15. And here the weight is going to be approximately 1.79 tons or 1.8 tons. So now number 10. This is here showing the relation between S, which is side length, M, which is the mass, and P, which is density. So now notice the density of gold is 19.3. So if density, so then density, this is my P. Then we're going to calculate the mass of gold, given that the cube has a side length of 3. So if side length is 3 centimeters, then this is my S. So notice how here S, well, S is 3. So 3 is equal to, here we go. I've got my cubed root of, do we know what M is? No, we are calculating the mass. That's what we're looking for. So M divided by, do we know what P is? Yes, P was our density, which is 19.3. Now we can go through and solve. Well, notice how do we multiply both sides by 19.3? Well, no, because notice how everything's inside of this cubed root. So, and it's by itself. So we got to first get rid of that cubed root, which the inverse of that is not squaring it, but cubing it. So we're going to cube both sides now. And I've got 27, which is equal to M divided by 19.3. Now that M here, we got rid of our cubed root, and M is being divided by 19.3. Now we can multiply both sides by 19.3. And so the mass is going to be approximately, because here they cancel out, you end up with 521.1 grams. So now in number 11, given electric power, we're using this formula here, P is equal to I squared times R. So which of these equations is equivalent to that represents? Notice we're solving for I. So here I've got P is equal to I squared times R. Well, if we're solving for I, notice how right now it's being multiplied by R, so now I need to divide by R. So P divided by R is equal to I squared. So now that I've got I squared, what do we have to do here? Take the square root. Now notice how we have a fraction already here. So take the square root of the entire fraction. That's why the answer is D. So now last here, I'm ending with 12 through 14, going back to our transformations. So now in question number 12, which of these cubed roots represents translated 3 units down? Well, notice everything shows that, -3. So far, so good. Horizontally, so this is inside by a factor of 4. But remember, if it was horizontal and anything inside was opposite. So remember, anything inside is the opposite. So this factor is not 4, but 1/4. So I can go ahead and cross out A and C. Then we're talking about translated 5 to the left. And again, inside is opposite. That's why the answer was B. Because here, if you chose D, this doesn't represent 5 to the left. This represents 5 to the right. So then 13, which of these statements is false? So 5, well, notice how the 5 is on the outside. So now this is our vertical stretch here by a factor of 5. So again, it's outside. Remember, inside is what's going to be opposite. So this statement is true. Remember, we're looking for false. So now again, anything inside is opposite. So now the 2 here represents your horizontal, but by a factor of not 2, right? 1/2. So this is a horizontal shrink or a horizontal compression by 1/2. So again, C is good. Then here, this is x minus 1, which means, remember, right, again, inside is opposite, so that's not to the left, but 1 to the right. That's why the answer was D. And the -6 on the outside does show 6 down. So then 14, which equation represents the given? So now notice, right, sorry about that, with our kind of this position here and the shape of our graph, going on and on, right, in both directions, up and down, left and right, domain is all reals. This is our cubed root function. So I'm going to go ahead and cross out D because this just shows the square root function. Remember, square root function is just your half graph. So here now that I've got my cubed root, remember the cubed root always starts here at 0, 0. So we're always starting at 0, 0. So now notice this got shifted to the right. So which of these equations represents 2 to the right? Well, A, because again, anything inside is opposite. However, what if you want to check and make sure that you got the right answer? What tool, again, that you will have access to that you can check? Desmos. So again, you could graph these in Desmos just to check to make sure that you have the correct graph. So here is A. So again, notice we are going through that positive 2 here, and always check to make sure that even points also match up. Now, just to double check, you could even graph the others, right? So like, for example, here's A. Oops, sorry about that. Now notice here, it got shifted to the left, which makes sense because now we had +2, which shows the opposite. So that's now to the left 2. And then the other option, C, notice how it went up 2, not right 2. It went up, which makes sense because that +2 is on the outside, which represents your up and down.